Hi, everyone. So today we are going to talk all about automation for enterprise-scale Flutter development. In case we haven't met before, I am Anna, an engineering leader passionate about mobile development and quality. I am a Google developer expert in Dart and Flutter, and I talk a lot about developers' experience, productivity, and technical excellence on conferences and online. I'm currently leading the client platforms team in a UK fintech company called Tide, where we provide financial services platform for small and medium businesses across the globe. And we write our mobile application using Flutter. And to put the practices I'm going to share today into perspective, I'd like to first mention a few stats about our Flutter project. It has over 4 million lines of Dart code contained in a monorepo with over 600 packages, and it is non-stop contributed by over 100 of engineers. The majority of them are mobile engineers, but we also have backend and web engineers also contributing, and everyone is encouraged to use AI. And as you can imagine, this is a pretty aggressive environment where the architecture of our project and the team responsible for maintaining it, like my team, are put to the limit. And stable and mature automation is key to keeping the project in a maintainable state and actually pleasant to work with. So we use various automation techniques during different stages of development lifecycle to help us with that. And this is our agenda for today. We'll first talk about things you can apply locally on your machines. This will be the biggest section because as developers, we spend most of our time there, right? And improving our efficiency at this stage can have the most impact. Then we'll move to things that can be automated on a pull request review stage, automated builds and distribution, and we will wrap up with ideas for ongoing maintenance. As usual with my talks, I'll share a mix of basic and advanced ideas, so everyone will be able to find something new and interesting for their level. Some of the ideas I'm going to mention, we do use at Tide. Some of them we'd like to have, but just haven't gotten there yet. And some of them we decided to skip because tools are not good enough yet to give us the result we want in a reasonable time. But still, I will be sharing all of them with you today, so you can pick whatever works best for your project and team. So now let's start with local development. I will start, of course, with my favorite topic, which is code generation with Build Runner, because I believe it is a great way to automate some of your daily effort. I have spoken about it a lot already, so I will only cover it briefly now. Basically, various open source code generators allow us to write only a few lines of specialized code with annotations and get a lot more functionality out of it after they are run. For example, Freest enhances Dart classes with equals that does deep value comparison, meaningful to string implementation, and a copy with method that allows updating nullable fields to null, right? And Freest unions enable quick implementation of sealed classes hierarchy with all the same benefits. Adding JSON serializable to the mix also gives us quick, type-safe JSON deserialization and mappers. Retrofit can quickly generate REST API consumers with strongly typed data loading and automated deserialization of the response. Barrel files can maintain the package exports list based on the annotated top-level elements. And after such code generators are configured in the project, additional Dart code can be generated with this build runner command. Another way to get some code generated is to use pre-configured code snippets, also known as live templates, for smaller parts of the code, but which are frequently used, or just some particularly hard to type parts like these freeze models. This is an example of such a live template, creating a freezed class called fModel. Once it is configured, I can type the template name, and once I hit enter, all the boilerplate code is generated, so I can immediately start filling in the class fields list. I have already spoken about code generation a lot, including on this stage last year. In this talk, I share a lot of useful code generating packages, practical advice on managing a code base that extensively uses code generation, like speeding up the process, configuring build YAML files, analyzer, and so on. And if you prefer written content, here is my tutorial on code with Andrea platform. Now, generating code in a package takes time, and the smaller package is, the faster the process will complete for each individual package. And for this and for many other reasons, it is better for project maintainability to have it split into smaller packages, which in enterprise scale projects means quite a number of such packages. So modularity is an important principle we have to follow in the project of our scale, together with consistency. Thus, another type of code generation I would like to mention in this context is generating entire packages with predefined structure with Mason. This is a simplified example of a template we use to generate packages at Tide. It accepts a package name as a parameter and creates this structure with pubspec file, lib, and test folders. And this is how it looks like inside the template pubspec. Package name is applied, and all of the rest of dependencies are immediately in place. And if we look, for example, inside the template API file, it also uses the package name as a part of the API class name and generates boilerplate code that is necessary to use retrofit in this package. So you can imagine how much of a boilerplate can be easily created with such templates. After everything is configured, generating an entire package using a template is as easy as running Mason make. It will prompt for the package name and immediately create all the files using this name. And there is also a curated collection of community-created Mason templates called BrickHub, with plenty of useful templates to pick from. All right, next. The consequence of splitting the code base into many small packages is the need to perform the same operations on each of them. The new workspaces feature somewhat helps with it already, right? Now you can run pub get once per workspace, analyze and format all packages in one go. But still, there is a custom, if there is a custom operation to execute on every package, like running tests or running code generation, Melas can help with collecting a list of all packages and running this command one by one or in parallel. Here is an example of a command that launches code generation in all packages that are dependent on build runner, one package at a time, which is controlled by C1 parameter. Here is another example. It will run Flutter test in all packages that have test folder. So Melas supports many useful filters for packages. Without this C1 parameter, this command will process 5 packages in parallel, which is the default behavior. And here it will fail after identifying the first problem because of the fail fast parameter. If the command is used frequently, it may be saved to Melas scripts. Here the command test changes, changed packages and dependents will only collect a list of packages that were changed compared to the main branch, filter them by only those having a test folder, and will add a list of packages that depend on them and run Flutter test only on that subset. In this case, filters will only be applied to the set of changed packages, but all dependents will be included unfiltered. And after it is declared in malloc YAML file, it can be executed by just running malloc and a script name. Next. Well, I guess keeping the code base properly formatted is an obvious practice, right? It helps with readability and minimizes changes to review. I'll start with a very basic advice here. Enable format on save in your IDE. That way, whenever you save a file, it gets reformatted. Yet sometimes files get changed outside of the IDE by other tools like agentic AI and can still remain unformatted. And to help with such cases, there is a Dart format command, which will automatically format all Dart files in a provided path. Unfortunately, sometimes this command doesn't play nicely in projects that extensively use code generation and do keep generated files in the code base because they are not always properly formatted. Some generators, like retrofit or freezed, in their latest versions, turn formatter off, so these files will remain untouched, but files produced by packages like i69n or injectable will get modified by the formatter, and build runner will not be happy about any other tool modifying them. So for such cases, this command can be supplemented with reverting changes in generated files. But be mindful that this should only be done after meaningful changes are committed. And in projects that haven't yet migrated to workspaces, malloc can be used to run the formatter in all packages in one go. Next. While having zero tolerance for analyzer warnings is another obvious practice, which helps to quickly identify any new issue the moment it is being introduced. And apart from keeping an eye on the analyzer report in your IDE, analyzer warnings can also be identified with Dart analyze command. And actually, a lot of them can be immediately fixed automatically with the Dart fix command. First, run it with dry run parameter to review the suggested changes, and then apply them with apply parameter. And once again, in projects with workspaces, this command can run on all packages. But if the preference is only to address those packages that changed, or the project doesn't use workspaces feature, malloc can help with running it in bulk. Now, next technique, I personally don't use it, but I still want to share in case it may be useful for your development style. Git provides a way to fire custom actions before or after certain events, like, for example, commit or push. And as I say, pre-commit hook is run before the commit happens, and it is said to be useful for formatting or linting changed files. So it can be used to format Dart files. It still has the same downside of modifying generated files. But following the previous approach where we formatted all the package and then reverted changes in generated files is not applicable here because meaningful changes have not yet been committed, and this revert will actually delete them. So here is an example of an alternative approach where only staged Dart non-generated files are collected, formatted, and then staged again before committing. And similarly, you can force Dart analyze on the changes at this point. The downside here is that format command is much slower when called on individual files as opposed to the entire package. So as I said, evaluate this approach against your development style before applying. All right, one more recommendation is to have a checklist of things to perform on a new development setup. Whether it is someone new joining the team or one of the developers is getting a new machine, it will save a lot of time and headache. And here are a few things from our checklist focused on mobile development, like installing Flutter and associated tools, setting up Android and iOS development, and so on. And of course, where there is a checklist, there is an opportunity for automation. This can be done with any scripting language to your liking, and it will save a lot of time in the long run, especially in a big team. So these are the practices to consider integrating in your daily Flutter development routine locally. We spoke about various types of code generation and ways to keep the code base clean and consistent. Now let's talk about what can be automated on CI for pull requests, because we never push code to main, right? I'm mostly used to using GitHub Actions, so my examples will use their syntax, but I'm sure you can implement something similar with almost any CI. I start with the same set of practices we have just applied locally, but this time to ensure they were actually followed. For formatting, we are going to use the same Dart format command, right? Since we're talking about large projects that are most likely split between multiple packages, malloc will come in handy to run this command in bulk. On CI environment, speed and resources consumption are critical, so it makes sense to optimize the number of formatted packages by only selecting those that were changed, assuming that the rest of the codebase is already properly formatted. Since PRs can be open against different branches, not only main, here I'm updating the diff filter with the branch that is targeted by this PR. And then I'm using the same trick with reverting changes in generated files. Since this is a part of PR workflow job, we'll probably have something like this around. And finally, next step is to use git status to see if any non-generated files were changed by the formatter. And if they were, the script will print their names and fail the job. A small caveat here, somewhere before these formatting steps, there has to be a checkout step, right? And it is important to configure it to pull the entire repository history as opposed to optimized pull of the last commit, because otherwise malloc diff filter will not work. Another obvious check to make is to make sure that the project has zero analyzer warnings or errors. Once again, here the full repository history is downloaded, and malloc is used to run Dart analyze in all changed packages. But now here is also the include dependence flag, which means packages that depend on the packages that were changed are also included in the list to analyze. This is because developers could change the API of some package in such a way that it produces analyzer warnings or errors in packages that use them. And the same applies to zero failing tests policy. Tests better be run on all packages that were changed and all packages that depend on them, to make sure that no user of changed packages was relying on some assumptions about their implementation, which is now getting changed. There is opportunity for several optimizations here. First, use very good CLI to run tests instead of Flutter test. It can speed up running tests in a single package significantly, like 4 to 10 times faster. And also, well, this trick with limiting the number of packages is already quite an optimization compared to the straightforward approach of analyzing the entire code base. However, you can still imagine there are situations where some core utility package is getting changed and it is used across the code base. So when we include the dependence, it indeed means analyzing the entire code base. And for projects of our size, it means hours of CI time and waiting for developers. So we have enhanced this approach even further to analyze and test all the changes. Because we have so many small packages, we can split the set of packages to check into batches and run analyze or test with malloc on several smaller groups in parallel with GitHub Matrix feature, which saves us quite a lot of time. This is an example of a job that goes before the actual testing. It gets the list of all changed and dependent packages with malloc list and splits them into batches of n size. It then writes the result into the job output, so the next job can read from it and create parallel executions for each of the batches. But this approach eventually takes the same time of CI minutes, but for developers, the overall waiting time is significantly reduced. So we have talked about ensuring the code base is properly formatted, has zero analyzer warnings, zero failing tests. But there are many more practices to automate during pull request reviews, so I have listed just a few more. Enforce code coverage for all changed packages to be no lower than some threshold. Well, just don't forget to exclude generated files from the coverage report. Use dependency validator to make sure that no unused dependencies are in pubspec YAML file, or that all that are used are actually explicitly specified there. And you can also check if all dependencies have pinned versions specified with a simple YAML parser. Identify newly introduced circular dependencies with malloc list cycles. Otherwise, this may mess up with malloc diff include dependence filter, and you will not be getting any optimizations out of it. Validate licenses of newly added dependencies with Dart license checker. The licenses list it produces can then be compared to the one provided by the legal team in your company. Even more automation can be created around checking your team agreements. For example, that no package imports its own barrel file, that translation files don't contain any forbidden symbols, that widgets that have wrappers in the design system are not used directly in any UI, and the list can go on and on. Even having the PR template with a checklist of things that developers have to do before opening the PR is also a kind of automation. The only question you have to ask yourself is how much are you willing to wait and actually pay for all these checks to run with every PR. All right, now that we have developed some new feature locally, it went through the PR review and landed in main branch, it is time to deliver them to your end users. And let me start by something obvious. Nobody should be creating builds locally, uploading them to app stores and distributing, especially in the enterprise world, because this can go wrong in so many different ways. So it should be all automated and protected on CI. Firstly, the application should be implemented in such a way that it allows providing some build time configuration. So it can accept things like API keys or third-party integration tokens, which must be different between development builds and production. For example, this can be done with Dart defines. So then for development, these values can be provided, for example, by run configurations in the IDE or from the command line with Dart define from file. And such files may be stored in secure vault if your company is using one. And on CI, when creating production builds, these values should be provided from a protected source. For example, GitHub offers protected environment feature, which can be configured to require manual approvals before a job can run on such environment and read from its secrets. And it can then pass secret values as individual Dart defines. When developing locally, inevitably some security protections have to be turned off. Otherwise, for example, it may not be possible to sign the bindle with a local development key or debug the app on the simulator. But anyways, it is critically important to ensure that security practices are applied to production builds. That is one of the reasons why developers should not be creating production builds locally, because they may forget or misconfigure the protection, and if published unprotected, the application can be cloned, resigned, and published with malicious intent, or it can give an attacker clues on how to work around the protection later. Here is just a very high-level idea of what it may look like. First, Flutter build is called with an obfuscate flag, and then the application is signed and protections are applied. It is very hard to come up with a custom solution that provides a satisfactory level of protections if you are not an expert who is full-time dedicated to investigating new kinds of threats. So it's very likely to have a third-party solution here, and thus the implementation of the protection steps will differ from vendor to vendor. At the enterprise scale, probably your company has already signed a contract with some expensive security provider. But for other cases, and especially if you don't understand what I'm talking about, it is a must to integrate FreeRASP solution by Talsec. So now that we have the protected build ready, it is time to distribute it, well, accordingly to the release process agreed upon in the company. Generally, it is a good idea to make and distribute builds according to some schedule that not only disciplines the team, but also improves the predictability and makes it easier for business to plan new feature launches. And to proactively address some of your concerns here, with this approach, in case some feature is not fully ready, by the time of the schedule release, it should be hidden behind the feature flag. This is an example of a weekly automated schedule. For the distribution itself, there are various ways to automate the process of uploading and distributing builds. Fastlane is a de facto standard in iOS world, and it also has a good level of support for Android, so I'd recommend using it for both. So these are the builds that can be sent to app stores for review and eventually be distributed to end users. However, we are introducing changes daily, right? And require feedback from QA and product managers faster. Having builds only done once a week is too slow for efficient development process. But releasing more frequent builds publicly would create too much noise and inconvenience. So it also makes sense to have workflows that can be triggered ad hoc and upload builds to additional distribution channels. Engineers should be able to create such builds whenever it is needed, not only on schedule, and because they will only be accessible internally. For smaller builds, for smaller teams, those can be uploaded to closed tracks in Google Play and TestFlight. Bigger teams may find it more convenient to use Firebase app distribution. If you're interested in hearing more details about this approach, check out this talk from Flutter Firebase Festival, where we talked about configuring Firebase app distribution both manually and through automation. So far, we have talked about automating the application of production app configuration from some protected sources, applying production-level security protections, and automating the distribution process. A few other good ideas to automate can be automate increasing the build number with every build, collect dev changelog based on the titles of merged PRs, post a message with the changelog and other released information somewhere in the common communication channels, for example, in Slack. All right, the last category of automation I promised to cover is ongoing maintenance. These are the housekeeping tasks that we are supposed to be doing regularly to keep our project in a clean and maintainable state. One of the suggestions I have is to take care of PRs that haven't had any activity for a long time. Maybe they are no longer needed, it's just the author forgot to close them. Such a task can be scheduled daily and can mark PRs that have been neglected for n days as stale. And after X days, if no new activity happens, they will be closed. The same idea can be applied to stale branches. Run the check on a daily schedule and delete branches from X months old. Another helpful feature is to have a nudge about outdated Dart and Flutter dependencies. This list can be obtained with a simple dart pub outdated command. And at the very least, the result should be broadcast on a regular basis, so the team is aware of the need to have a look and plan for the update. But it is even better if there is a scheduled workflow that automatically makes the change, for example, with Dart pub upgrade or a custom shell script, and opens a PR with it. This will trigger all the checks that we have talked about in the previous section. So tests and analyzer jobs will help understand if there is any problem with the update and which has to be fixed, or if the PR is already good to be merged. And if the project is rather big, with a lot of dependencies, frankly speaking, it is unlikely that such an update can be done successfully without human interaction. And one of the things that can help is to declare a smaller list of critical dependencies that have to be taken care of in the first place, and only check for those. All right, this next idea I haven't tried myself, but I think it might be interesting to experiment with. Autofetch and apply the latest list of all linter rules available. Here I listed potential sources for existing rules. And then, in order to control which rules out of that entire list are disabled, they can be overridden to false in the analysis options file of your project. And once an automatic PR is open, analyze check will highlight violations, and then developers can decide whether they want to fix them or turn the rule off. So we talked about a few housekeeping tasks, but as usual, the list can go on and on depending on your project type and team needs. So to recap, today we talked about automation for local development, pull requests, builds and distribution, and ongoing maintenance. You probably noticed that some of the practices became possible thanks to our architectural decisions we made in our project. So if you're interested to learn even more about our architecture and how we do Flutter development at Tide, check out this video where I go through a lot of technical details. So that's it for today. I'll take your questions off stage. You can find me in the Flutter community booth. Happy automating!